Scatterplots and line of best fit. Let's start with some terminology. A scatterplot is a graph that has points which show the relationship between two sets of data. The independent variable corresponds to the x-axis, and the dependent variable corresponds to the y-axis. A correlation is a relationship that's evident between the two variables. A line of best fit, or trend line, is a line that passes through the middle of the points representing linear data that have a correlation. So we'll start with an example of a scatterplot. In this example, we are comparing a person's weight with their height, and each dot shows one person's weight versus their height. Weight is the independent variable, while height is the dependent variable. And as far as correlation, this data shows a positive correlation. In general, the more a person weighs, the greater their height. So what we want to do is consider the trend of the data points. And so I've drawn this kind of strip, rectangular strip that kind of tends toward in the same direction as the points. And if we draw a line through the middle here, we can call this our best fit line. Now there's an exact way to get a line of best fit using a graphing calculator, but this is an informal line of best fit. And what we want to do to give you an understanding of why this is the line of best fit is we want to take each data point and then the vertical distance between that data point and the line. And we'll call this distance 1. And then we have distance 2 and distance 3. And we're going to look at all of these vertical distances between each data point and the line of best fit. And the line of best fit is actually the line which, when you take each distance and you square it and you add those squared distances together, minimizes the distance. So that's what we mean when we talk about, you may hear the word least squares regression, and that's the general idea of that. But for our purposes, we're going to just get the informal line of best fit by the line that goes through the middle of the data points in the same trend. All right, so let's look at an example. The local ice cream shop keeps track of how much ice cream they sell versus the 12 o'clock noon temperature on that day. Here are their figures for the last 12 days. So every day at 12 o'clock noon, they recorded the temperature and the ice cream sales. And they were wondering, is there a correlation between the temperature, in this case degrees Celsius, and the sale in ice cream that they sold that day in dollars? And so they made a scatter plot. And they put temperature as the independent variable. And we went from, looks like 11.9 is the day that it was the least temperature. And then the greatest temperature, well, the greatest temperature is still less than 26. So we could go from 10 to 26 counting by twos, because on a graph, on a scatter plot, we always want to use a convenience scale and an interval. Right now for sales, same thing. A convenience scale and interval, we can start at 0 and go all the way up to 700, counting by hundreds. And then what we do is we put the data points down. We go over to 14.2 degrees on the x-axis and up to 215 in the vertical direction. We go over to 16.4 and up to 325, and we can put all these dots here, and we can see that there is a linear positive trend to this data, and so we can sketch our line of best fit. And now that we have our line of best fit, it's a good thing. Very often you'll be asked to interpret, problem solve using this line of best fit. So if the temperature is 21 degrees Celsius, what are the expected sales? So we're going to find 21 degrees on our x-axis, and we're going to go up to the line, find where the data point would be, and go over to the y-axis. And so we could predict that if the temperature is 21 degrees Celsius, the expected sales would be 450 degrees.